Hi, welcome back. We're going to be talking about metric prefixes and SI units. You're probably already familiar with certain parts of the metric system. For example, units of measurement like centimeters, meters, kilometers, liters, degrees Celsius, etc. But in science literature, we actually use a subset, a smaller part of the metric system. So all the metric units there in blue, the SI units, which is the subset that we use, are just a few specific metric units within that whole system of metric units. SI, by the way, stands for System International, or the International System of Units. It's written in French, typically. That's the French flag. So they use the adjective in a different place than we do in English, but it's the International System of Units called the SI units. There are many units systems for measurement. And we here in the United States use a lot of the ones that were designated as the imperial system or the British system for units. So time is measured in seconds, length is measured in things like feet or yards, miles, inches, and so on. Mass is measured in a kind of a strange unit you might not have heard before. It's actually called a slug. It turns out if you put a slug, that's a unit of mass, on a scale on Earth, it weighs about 32 pounds, so maybe you're more familiar with the weight rather than mass. We'll talk about that later as we need to. In the metric system, time's also measured in seconds and minutes and hours and days, just like it is in every other system. Length, though, in the metric system would be measured in something like centimeters or kilometers or meters. And mass in the metric system, you're familiar with this, I'm sure, in grams or kilograms or milligrams. But the SI system, remember, is a subset of the metric system. So all of these units here are metric, but not all of them are SI. It turns out time is pretty easy. In the SI system, we also use the second. It's the same. In the SI system for length, we use the meter, which is the base unit of length in the metric system. But in the mass part, we do something a little different with the SI system. We don't use the gram, which is kind of what you might think we might use, which that's the base unit. We actually use the kilogram as the standard unit for mass. Remember, a kilogram is about 1,000 grams. So on Earth, if you put a kilogram on a scale, it weighs about 2.2 pounds. So it's a larger unit of mass than the gram. A gram is a pretty small mass, about the mass of a paperclip. But a kilogram is a couple pounds. Put it on a scale. Slide this one across. We should now talk about prefixes that are used in the metric system. So you might see these prefixes used on units of time like seconds or meters or any other base unit in the metric system. And we'll start with the larger ones and work our way down to the smaller prefixes. This base unit, there's no prefix at all for the base unit. That base unit would be the meter or the second or something like, or the gram. And these prefixes get larger as we go up here. So kilo, which is a lowercase k, means 10 to the third or 1,000. Mega, which maybe you're familiar with in terms of FM frequencies, megahertz, or in your computer, maybe at home, is a capital M. That means 10 to the sixth power, 1 followed by 6 zeros. That's 1,000,000 times. Giga, or a capital G, is 10 to the ninth, which is 1,000,000,000. And tera, which is a capital T, 10 to the 12th power, which is 1,000,000,000,000. So if you see something in terameters or terahertz, that's trillions of meters or trillions of hertz cycles per second. Let's try to slide these deftly. There we go. Across. As we work our way down to the smaller prefixes, I put the base unit here up at the top, and we'll work our way down to the smaller prefixes. You can kind of imagine the last board as being up above this one, and then we all work our way down. The next one that we're likely to encounter in our class anyway is deci, which is 10 to the minus 1, means 1/10, decimal, 10 to the minus 1. Centi, little c, 10 to the minus 2, that's 1/100th. Centi is the same prefix, the same root origin as the word century for 100 years, but when it has the I at the end, that means it's tiny, so 1/100th. Milli, that's 1,000th. A lot of people get confused and think that milli means millionth. but milli is like millennium or 1,000 years. So this is 1/1000. Micro, which is 10 to the minus 6, that's a millionth. So micro actually means a millionth, not milli. The symbol for milli is a lowercase m, but notice that we can't use m again for micro, so we went to this Greek letter, the Greek letter mu, mu. And it kind of looks like a cursive U with a long tail on the left side. And then the last one we're likely to encounter is nano, and nano means billionth, or 10 to the minus 9. So make sure you have those down in your notes. You can refer to them later when we need them. If you're converting things with prefixes, there are some easy ones and slightly more complicated ones you can do. If you're asked to convert, say, from so many centimeters to meters, if you're going to the base unit, that's a fairly simple conversion. All you need to do is recognize that centi, that prefix there on the meter, means 10 to the minus 2. So just substitute the meaning for the prefix. So instead of writing 16 centimeters, you instead write 16 times 10 to the minus 2 meters, because 10 to the minus 2 is centi. That's what it means. If you want to leave it that way, 16 times 10 to the minus 2, that's fine with me. If you pop it into your TI calculator, it'll convert it for you. Or you can go ahead and move the decimal place over 2 spots so it reads 0.16 meters. Same thing with a larger unit, with a larger prefix, I should say. So if we have 5 kilometers, how many meters is that? Well, kilo means 10 to the third. And so just substitute 10 to the third in there for kilo, and you get 5, instead of kilometers, you get 5 times 10 to the third meters, or 5,000 meters. So that's a simple substitution. If you're going from prefix to prefix, then it gets a little bit more complicated. And I have a method that I like to talk to students about, and I think it works for me, and hopefully it'll work for you too. So in this first example, example A, we have 52 grams, and we're converting that to kilograms. So I take the prefix here. There isn't a prefix. Remember, if there's no prefix, that's 10 to the 0 power. And I take the prefix over here, 10 to the third, and I subtract the first prefix from, or so the second from the first. So it goes 0 minus 3, which is minus 3. So negative 3, I should say. And so that means 52 can be written, grams can be written as 52 times 10 to the minus 3 kilograms. And we've converted it. And again, you can leave it that way, or you can move the decimal place if you want. Here's another example. 2.3 kilograms is how many grams? Well, kilo is 10 to the third. And so this has no prefix, so 10 to the 0. And so that would be 3 minus 0, which is 3. And so instead of writing 2.3 kilograms, I write 2.3 times 10 to the third power grams. And the last one is the most complex of all, because you've got 2 prefixes, the one on the beginning and one on the end. But the process is the same. So 520 centimeters is how many kilometers? It turns out it's a lot less than a kilometer, because it takes 1,000 meters to make a kilometer. We don't even have that. But in any case, centi means 10 to the minus 2, and kilo is 10 to the third. So it would be negative 2 minus 3, which gives you negative 5. So negative 2 minus 3 gives you negative 5. And so I write 520 times 10 to the minus 5 kilometers. And again, you can leave your answer that way, or you can move that decimal place 5 spots over and get the answer there.